Alright, so this is a video lesson for Thursday, the 7th of November, for those of you who are out. A couple of things that we did. We looked at some circular motion free body diagrams, and we looked at the physics of swinging a bucket of water around your head. So we'll just take those things in order. First, the circular motion free body diagrams. So the first thing I want to imagine is a tether ball. You have the pole here, and you've got the string out like that. The ball is right there, and this thing zips around in a circular path like that. All right, so here's what I'd like to do. One is to sketch the free body diagram for this situation. Two, make sure I set up the axis system, set up the axes. Three, I want to show the changing direction acceleration, sometimes called the centripetal acceleration. And then four, I want to write out the net force equations for the axes. All right, so let's grab our pen here. Let's do the ball right here. We'll do the free body diagram. All right, so there's a tension force acting like that. We'll call that tension string on ball. And then there's the downward pull from the earth on the ball. That's just the weight of the ball. All right, now to set up the axis system. So we want one of the axes to go through the radius of the circle. Now this is going around in a circle like this. And so the center of the circle is right here. So the radial axis here actually is like this. There, and then the other axis is right here. Rotate this guy like this, and this will be our y-axis. Okay, and so this is our radial axis because there's the center of the circle, goes through the radius out to the object, and this is the x-axis, or maybe we'll call it the y-axis. All right, now the centripetal acceleration, or the center-directed acceleration, is directed this way, in toward the center of the circle. And the the net force equation looks like this. Along the radial axis, you have tension, string on ball, and that's the only, along the radial axis. Erase that. And that's the only force along the radial axis, so that should equal MAR, or MAC if you prefer. Either one of those are fine. And then along the y-axis, we have the tension string on ball in the y direction minus earth on ball, and that'll equal MAY. Which in this case is 0. Now here's another one, and maybe you can try to figure this one out. So this is like a pendulum. Here's a string, there's the pendulum, and it swings back and forth like this, back and forth. All right, and so again, free body diagram, net force equations, axis system, etc. Why don't you pause and see if you can do that one yourself. All right, so let me make the axis system first. The center of the circle is over here. It's swinging like this. Center of the circle right there. So let's bring our axis system up like this. And we'll rotate it so that it goes through the center of the circle and through the object. And then this will be our other axis, which will bring, and it will always be perpendicular. And then we can draw some of our forces. We have our tension force up like that. And we have our weight force down like that. Now this axis system is different because the circle that it's going around is a little bit different. This one, again, the center's up here, swinging in a circle, or at least a partial circle like that. All right, so this will be weight, earth on ball, let's say. And let's say this will be tension, string on ball again. All right, and then the next segment we'll just pick up.